In 1970, Norman Borlaug was awarded the Nobel Peace Prize for his efforts in developing semi-dwarf varieties of wheat. Semi-dwarf wheat is 1/2 to 2/3 shorter than the wild type or tall varieties of wheat. If you look at the photo on the left, you'll see Norman Borlaug standing in a field of Sonora 64, one of the first semi-dwarf varieties of wheat released for farmers. And you can see that it's shorter than the surrounding fields that includes the wild type taller varieties of wheat. Semi-dwarf varieties of wheat are advantageous because they do not lodge or fall over in the field when inorganic fertilizer is applied, and this results in an increased yield. It is estimated that Norman Borlaug directly saved 1 billion lives from malnutrition and starvation through the development of semi-dwarf varieties of wheat. However, it is unknown how breeding for above ground traits alone, such as shorter stature, higher yield, or increased disease resistance, has resulted in changes to below ground traits over time. And that's where my research comes in. I've selected 10 varieties of wheat ranging from 1808 until 2002 that includes both semi-dwarf and wild type varieties of wheat to evaluate potential changes because of breeding. I'm showing 3 photos on the bottom of the screen. On the left is Goins from 1808, a wild type tall variety of wheat. In the middle is Norin 10 from 1935. This is the first ever semi-dwarf variety of wheat, and it is where the genes for dwarfism came from. And on the right is Encore, a modern variety of wheat released in 2002 that is a semi-dwarf. And if you look at these photos, you can see that the root system length has changed over time and is shorter in 2002, and the number of roots has decreased over time, especially those fine laterals that are almost non-existent on Encore. And when I grew out all 10 varieties of wheat, this is indeed what I have found, that over time we have selected for root systems that are shorter with less roots unintentionally. And this is regardless of if the plant is a tall or a semi-dwarf variety of wheat. Now I'm also coupling that information on root system architecture with chemistry because it's not just about where the root is in the soil, it's about what it does when it gets there. And it is my hope that breeders can use this information on below ground traits to begin breeding for plants that incorporates above ground and below ground traits to fuel the next green revolution that will save another 1 billion lives from starvation.